Welcome back, children. Now let us move to the worksheet number 3 of laws of motion. So here we start with the first numerical of worksheet 3. The relation between force, mass and acceleration found by. So children, in laws of motion we have come across with the 3 laws of motion. Newton's first law of motion, okay, which introduces the force. Newton's second law of motion, which gives the relation between force, mass and acceleration as F is equals to ma, or the rate of change of momentum is defined as the net external force applied. And Newton's third law, for every action there is an equal and opposite reaction which acts on two different bodies. So first of all, let us try to understand very well regarding the first question. The relation between force, mass and acceleration is given by, so this relation was given in Newton's second law. This defines force. So as we know that force is equals to mass into acceleration. So relation between force, mass and acceleration was discussed in Newton's second law of motion. Second law of motion. So let us go with the second question, children. The relation between the momentum and the force acting on it is. Children, from the Newton's second law, we also know that the rate of change of momentum is defined as your net external force applied on the body. Okay. So, just now we have discussed that F is equals to ma. So, Newton's second law says that F is equals to ma, where the acceleration is defined as the rate of change of velocity. Acceleration is defined as the rate of change of velocity. Change in velocity upon time. Okay. So, that is change in velocity is v minus u by time. So, substituting the value of a in the above equation, we have F must be equals to m times of v minus u by t. So, where is the correct option, children? Here goes your correct one, that is F is equals to m times of v minus u by t. Hence, second option must be true. So, moving ahead with the next question, that is question number 3. The rate of change of momentum acting on a body is 5 kg meter per second square. The force acting on the body is we have discussed that the rate of change of momentum is directly proportional to the net external force applied. Newton's second law. Okay. So, the rate of, that means F is proportional to dP by dt, or F is equals to K times of dP by dt. For K is equals to 1, F is equals to dP upon dt. So, this was discussed in Newton's second law. So, what was given as the rate of change of momentum, that is dP by dt itself is given as 5 kg. So, this is given as 5 kg. If dP by dt equals to 5 kg, then what about the force, children? Force is also equals to 5 kg. So, the force acting on the body is, it's not kg, kg meter per second. So, if dP by dt is equals to 5, force is also equals to 5. But remember that change in momentum upon time is momentum units is kg meter per second upon second. So, finally, we have kg meter per second square. Force, general notation in SI system, generally it is measured in Newtons. So, whether it is kg meter per second square or Newtons means the same. So, how much is the value? 5 Newton. F itself is equals to dP by dt. Whether it is measured in Newtons or kg meter per second square means the same. Okay. So, now let us move to the next question, children. Question number 4. Force measures rate of change of momentum of a body. The rate of change of momentum of a body is given by force. So, where is the correct answer? Rate of change of momentum. So, fourth option must be true. Okay, moving ahead with the next question, that is question number 5. The rate of change of momentum, force. The rate of change of momentum itself is force. The same questions are repeated, children. Nothing new. So let us move to the 6th question. The correct relation between force, mass and acceleration is. So just now we have discussed that F is equals to ma. So what is the correct relation between force, mass and acceleration? F is equals to ma. So option 3 goes good. Okay. So now let us also discuss with the next question, that is question number 7. Force is the cause of. If force is the body, so slowly moving body may get accelerated because of the application of force. Force is there, body accelerates, mass into acceleration. Some body of mass m is there, force applied, it accelerates. F equals to ma. Force is the cause of motion. Body is at rest. Force is applied, the body moves. So the body is set into motion. Because of force, acceleration is created. Because of the force, body is set into motion. Because of the force, the rate of change of momentum is produced by the net external force. So change in momentum is also produced. Initially it was moving with some velocity u, force is applied, velocity is changed to v, then change in velocity equals to v minus u, change in momentum equals to mv minus mu. So change in momentum is produced due to the application of force. So force is the cause of acceleration, cause of motion, cause change in momentum. So all the above given concepts are true. So the only correct option among this is option number 4, all of these. Now let us move to the 8th question, children. A force can be completely described by. Force, is it a vector quantity or a scalar quantity? Of course, force is a vector quantity. It has magnitude, it has a direction, specific direction. So, a physical quantity which has both magnitude as well as direction is defined as a vector quantity. Okay, so as force is a vector quantity, it has both magnitude as well as direction. So force can be completely described by its magnitude as well as direction. Not only magnitude, not only direction, both. So option 3 must be true, children. Okay. So now moving with the next question, that is question number 9. The acceleration of a body is to be doubled from its initial value. So what they have to do? Acceleration is to be doubled. Initially a, now it is 2a. What factor is the acting force to be increased? So as we know the formula for force as F is equals to ma, this clearly implies that F1 is equals to m1a1 and F2 is equals to m2a2. Equation 1 and equation 2. So dividing these two equations with one another, we have F1 by F2 is equals to m1a1 by m2a2. But what is given? Acceleration of a body is to be double. Body remains same. Body remains same implies mass is m1 is equals to m2. Let us suppose this as some m. Mass m1 is equals to mass m2. Let us suppose this as some m. And what else is given? Acceleration is to be doubled. If a1 is equals to a, then a2 will be double of that previous value. a2 will be 2a. Substituting all the values over here, we have ratios of forces F1 upon F2 is equals to m1 is taken as m, a1 is taken as a, m2 is taken as m, a2 is taken as 2a. Okay, children. So now simplifying this further, a gets cancelled and you are left with 1 upon 2. So cross multiplying, if you have f1 by f2 equals to 1 by 2, then cross multiplying, bring this f2 here and 2 this way. So f2 is found to be 2 times of F1. F2 is equals to twice of the force. This implies F2 is equals to 2 times of F1. So how much it is? It became twice, 2 times. So the correct option must be option 2. So the force, what factor is the acting force being increased? It increases by 2 times. Okay, children. So with this we have completed with the worksheet. Okay. So keep practicing, children. Until then, take care. Thank you.